Hi guys, this is Krish. Krish here, and today we are actually meeting up on supply chain optimization, a case study of supply chain optimization. So thank you very much for joining this session. And if you're joining late, so please do join, and we'll be getting the entire recording of this program on our social media channels. You can visit our social media channels or YouTube channel. So our YouTube channel is at the rate supply chain dot analytics is our YouTube channel. You can visit our YouTube channel in case if you are joining late, or if you want, or in case you want to repeat this session, or you want to revisit the session, you can go to our channel. This is our YouTube channel, or you can visit our YouTube, Facebook, LinkedIn. We have already sent the invites on the LinkedIn to people who are connected with us over on the LinkedIn, and we have also sent the invites on Twitter. Also, you can also follow our Twitter channel. So you can visit our social media channels where you can actually revisit the entire video. Or if you're joining late, or if you're not able to join, you can again revisit the channel. So let me repeat once again. My name is Krish Naidu. I'm Krish Naidu. I am a metallurgical engineer with an experience in the field of process engineering, process metallurgy, supply chain consulting, supply chain software development, supply chain analytics, lean, Six Sigma, business process transformation. So I have almost an experience of 23 years in the field of supply chain, and currently I actually in the last 6 years I'm actually working for Mathnal dot Tech. I'm actually the founder of this company. This is supply chain analytics company. I'm the founder of this company. So let me take you to the website of our company, and then afterwards we're going to start our today's webinar topic. This is our website. So we are providing consulting services. We're providing on various aspects of supply chain, investment analytics, demand forecasting, inventory analytics, vehicle optimization, supply chain, cost optimization, lean and Six Sigma, data visualization, like using Power BI, supply chain risk analytics, procurement optimization, inventory optimization. So you can visit our webpage to get the understanding about what kind of uh, what kind of programs. And we are providing the consulting services. Similarly, you can visit. We're also into these training services. So this is our courses. You can visit our courses on over here. So we'll be, and if you have any questions, or if you want to get the training from us, so you can connect with us through the website, or if you want to connect over to my email. So I'll be sharing my email here, Krish Naidu @mathnal.tech. Or if you want to connect me on the phone through WhatsApp or mobile phone, you can call me on my number or text me on the number 8977 924 637. This is an Indian number. So I live in India, and the company is based out of India in Hyderabad. So you can actually connect with us on this below details. Right. So let's move towards our today's webinar topic. And today's webinar topic is supply chain optimization. And the case study we are looking is product mix optimization to generate profits. Okay. So we have a case study with a case study of an oil company in an oil manufacturing company, right? So what they're doing is that let me share what they're doing. So they are actually buying the oil from various sources, right? Suppose they're buying an oil one from supplier one, oil two from supplier two, oil three from supplier three, oil four supplier five. So like this, they are buying different sources of oil from from their various suppliers. Suppose they have 11 sources. So what they're doing when they buy this oil in barrels, they put those oils into a tanks. Tank one, okay, tank two, tank three, tank four. Like this, they are putting tank 11. There are 11 tanks. And the reason why they're putting this oil in various tanks because each oil has different chemistry. All these oils have different chemical components or different chemistry. Okay, or the percentage of the different percentage of the components. So the pricing of the oil depends upon the oil type. So the component, suppose they have to make an oil because they have to process this oil. They have to process this oil, right? They have to process. They have to processing, and they will do the processing by doing the mix of this oil. Okay. After mixing this oil, they have a desired chemistry or the target chemistry. Okay. So when they mix the oil from these various sources, which is being bought from different suppliers, right? They're going to do the blending. The processing is called blending, mixing, blending process. So in this blending process, they when they blend, after blending, then they have certain objectives. Their objective is that they need to achieve certain target chemistry of each different kind of components. Let's say component A, component B, component C, component D. Right. So they want something like 30% of B, 10% of B, 50% of C, 40% of D. Right. So they have certain kind of chemistry for each chemistry or percentage of the percentage component for each percentage of the each component in in the total mixture. So that is what one of the target they have. Okay. So and as we know that if you are buying oil from different sources, each based upon the chemical components, chemistry or chemical components percentage, the price of the oil will also be different. Suppose oil one could be, could be like say like could be say $20 per barrel. This could be oil two could be $15 per barrel, right? Oil three could be $10 per barrel. Oil four could be $5 per barrel. Oil 11 could be $40 per barrel. I'm just putting imaginary prices here. The prices are actually quite different. So once these oils are purchased from different kind of suppliers, so they will have a different kind of pricing. They are different kind of pricing. And finally, what they have to do, they have to mix this, and these oils are stored in different tanks, so that the parity between those oil mixtures are maintained at this level, at the input level or the storage level. And once these oils are mixed into a blending unit, the output has to be certain kind of target chemistry. This is one of the things we need to optimize. So the target chemistry has to be optimized. But at the same time, we need to see that the blending process, the blending process is a manufacturing process, right? Blending is a manufacturing process or manufacturing process. So this blending process, when we're doing, so we need to take the right mixture of oil from tanks. right? So what is the meaning of right mixture of oil from tanks? Right mixture of oil from tanks is that it should actually minimize the cost, minimize cost. Suppose we are taking the oil from different kind of tanks, and each tank has different kind of pricing. Each kind of different kind of costing, right? Because this is being purchased from different kind of supplier based upon the chemistry of the oil. So when we are trying to mix the oil, so we should not see that we are taking the best oil, the maximum in maximum volume. It should not happen like that, right? So we need to see that we have to optimize our mixture, optimize the mixture of oil from the various tanks in the blender in the blending process in order to save the cost as well as in order to achieve the target chemistry. So we need to achieve the target chemistry. We need to minimize the cost, right? And we need to, if you have to minimize the cost, it means we need to have a weighted ratio of the oils. Suppose I have oil one, oil two, oil three, right? Like this, I have to oil 11. So I have to take certain weightage. Means I'll take 20% of oil one, or maybe 10% of oil two, or 5% of oil three, or maybe 1% of oil 11. So certain weightages we need to take. So that weightage is a variable. So here, this weightages of oil, right? This weightages of oil is a variable. Or we can also create a solution. We can also create a solution where we say the volume is a variable. The volume of oil is a variable. Either we can take the weightage as a variable, or we can take volume of the oil is a variable, right? So we have to take certain degree or certain volume of the oil so that in order to minimize the cost as well as achieve the target chemistry, right? So we have to achieve a target chemistry of the oil as well as we have to pick the volume of the oils from different tanks in such a way that our cost of production remains, or the cost of production means the cost of raw material. Here we say the cost of raw material because we are picking the oils from the tanks. On oils from the tanks is the raw material. Oils from the tank is the raw material. So what we are doing, we are trying to optimize the cost of raw material. We're trying to optimize the cost of raw material, because we are taking the volume from the oils. At the same time, when we're trying to, at the same time, when we're optimizing the cost of raw material, we're also optimizing the target chemistry of the oil, because our customers are looking a refined oil, because we have to sell the refined oil to the customers, right? So when we sell the refined oil to the customer, it needs to have certain chemistry. So that chemistry target has to be achieved. And when we sell the refined product to the customer, that is the selling at a selling price. Some selling price is also involved, right? So if we optimize the cost and selling price is fixed, if selling price is fixed, right, and cost of raw materials is required to be optimized, right? So if I write the profit formula, profits, okay, profits for the volume is equal to selling price for the sales volume minus cost price of the sales volume, right? So this cost price is allowed to be optimized, but sales price is not allowed for optimized. So this is allowed to be optimized, but sales price in this particular case we are not allowed to optimize. sales price is not allowed to in this particular case, but maybe in different case we may have to optimize the sales price also, and the cost price is of these is allowed to optimize. So now if you look at, we get the profits here. Profits by using this particular formula, we get the profits for certain amount of oil volume, which has to be sold to the customer. Suppose if I'm saying that the profit for 1,000 units of 1,000 barrels, 1,000 barrel is 200,000, right? 200,000 US dollars, just for example. So what is the profit per unit then? Profit per barrel. Profit per barrel is 200,000 divided by 1,000. So it's coming around 200 per barrel. These are profit per unit. So this is what we are going to optimize in our problem, because we have to we have to see that how we can optimize profit per unit in the case. So once again, I'll repeat the process. After that, we'll go into the solutioning or data process. So first is that our objective is that we are doing product mix optimization. So we are buying oil from various kind of suppliers, right? And suppose we are buying oil from some 11 suppliers. So we are storing that oil into 11 tanks. And after storing that 11, and each of the tank, each tank which contains the oil has certain chemistry of the oil, right? So we have 11 tanks, and each tank has a oil, and each the oil which is in the tanks has different chemistry for all the 11 in the only on the 11 tanks. So what we have to do now we have to do the blending process, or we have to take a blend from the all the 11 tanks, and before blending we need to do the optimization so that we take the oil from the tanks. So blending process, in the blending process, when we do the processing, so we have some certain target chemistry, right? And this target chemistry is being ordered by the customers, for which we have to sell. So this target chemistry is there. So when we do the optimization after blending, we need to the blended output has to achieve this particular target chemistry. But the point here is that when we do the blending, the cost of raw materials, cost of oil, when we do the blending, we need to optimize. So, so when we take the oil from the different kind of sources, from the sources means our 11 tanks. So when we take that oil from different kinds of sources or from the oil tanks, we need to see that the overall cost of raw materials in the blending process has to be minimized, and also we need to at the same time we need to also achieve the target chemistry, right? That is what the objective. So, but since we know the sales price is not allowed to optimize, only the cost price of raw materials is only the cost of raw materials is allowed to optimize. So the profits, how are we going to calculate? Is the profit for the profit formula is selling price minus cost price. Selling price for the volume. Suppose we are selling for 1,000 units. What is selling price for 1,000 units? Cost price of 1,000 units. So we get a profit for the 1,000 units. Now the profit for 1,000 units is equal to some, let's say, 200,000 US dollar. So profit per barrel or profit per unit will be, we're going to divide this overall profit by the volume. So this is what we're going to optimize. So please do visit the video, or if you have any questions, you can post on our social media channels, or you can also email. I have already shared my email ID and my phone number. So you can also, email me or WhatsApp me if you have any questions on the scenario of this of the scenario on the problem, right? So this is what the scenario which we are going to work on this particular case today. So now we move into the case. So let's go into the data and let's see what we can achieve. So if you look at here, I have the various tanks over here. I have almost 9 tanks, tank number one to tank number nine. And what is the maximum storage capacity of each tank? And we have the target chemistry for this. Look at here. So what should be API? What should sulfur? What should be TAN? What should be Ni plus P? What is MCRT? What is C2S5? These are all the components of the oil. So what should be the chemistry? What should be the chemistry of this particular What is the chemistry of this? Each the oil which is contained in this each of the tanks that is already mentioned over here, right? Now what we do, we will take the oil from those tanks, right? We'll take the oil from those tanks, and suppose oil one has a chemistry of this, oil two has a chemistry of this. So now suppose we have like this, we have 29 type of oils which has been taken from the top sources. The 29 types of oil we have, and each oil has a chemistry, certain chemistry over here, right? Which we have already seen. Okay. So this is the chemistry for you. Now what we will do, we're going to blend this 29 type of oils, right? With an objective that we are able to achieve target chemistry, but also we are able to achieve the optimization of the cost of raw materials. Okay. So that is what the case study is. So now let's say, so there is a, in this case, what is the minimum minimum volume of oil we can use, and what is the maximum volume of oil we can use? Those things are clearly defined over here. So if you look at here, this is, the minimum oil we can use is 0 barrel, maximum we can use 1,000 barrels, right? The price of, the price is, price per barrel is point 0.5. Okay. And this is the cost of delivery. So we'll know, so this is zero point 0.5 and this is 1.5. Cost of logistics 1.5 plus zero point 0.5 is equal to 2 unit, 2 per barrel. Right? So 1.5, zero point 0.5 is equal to 2. 0.75 plus 0 is 0.75. Zero point 0.5 minus 2 is 1 minus 1.5. So this is what we're getting our price delivered. So this is the cost of total cost of logistics. Yes, the material cost as well as the cost of shipment. Okay, so what we're going to do is we're not going to consider the total cost of logistics. We're going to only consider the material cost. We're not going to, because our focus is to minimize the material cost, right? We're not going to consider the cost of logistics over here. To minimize the cost of logistics, that is a different case study. So we are not also going to the produce case study over here. So now if you look at here, Uh, so these are the markets. We have the markets over here. So we are going to optimize. We are going to there are 7 markets for we need to optimize. So market one has the maximum requirement of 1,000 units, minimum requirement of 1,000 units, and maximum requirement of 3,000 units. So this is market one where we are going to sell after the optimization, after we achieve the optimization. So there are 7 markets over here on which we have to sell. So here, if you look at the first market, market one, for which we are going to build this case. So here, if you look at, we have minimum volume, which we require 1,000 units, maximum volume is required 3,000 units for the market. And the the selling price per barrel is 2.5 units. Okay. And this market wants the target chemistry around this one. Okay. This is target chemistry this market one wants. So market one has a minimum requirement of 1,000 units. Market one has a maximum requirement of 3,000 units. Maximum market one is selling at 2.5 units per barrel, and the chemistry requirement for each of these particular component is given by the market one. Right. So now we know what does the market wants and what is our process. What kind of process we have. So what I'm going to do is I'm going to build a case now. So what I'm going to do, I'm going to remove this cost of logistics because we don't want the cost of logistics. Sorry. Yeah. I'm going to remove this price delivered. We don't want the price of delivered here. We're just going to focus on the material cost. Okay. Now we know the volume, right? So we have to create a volume column here. So we need to know the cost raw material. So how much volume we need per oil type here.